Uses solid primitives, prisms, spheres, cylinders, cones, and Boolean, that is union, subtraction and interaction, to create the solid model. The lack of editing or redimensional capabilities. If there is a change in the design, the model in most cases will have to be reconstructed. Some what they call freely downloaded from the net package which I use comes from this. But then since usually we have done a real big goof, it is not a small adjustment, I am more used to making the whole thing again. I will show you a last example in the end. Prep method start with one or more wireframe profiles, create a solid by extrusion, sweeping, revolving or skinning these profiles. Boolean operations can be used and the solids from these profiles can be made. Solids can be created by combining surfaces which have complex shapes through a sewing or welding operation, used for example to create the body of an aerodynamic vehicle such as an airplane with designed wing profiles. These two methods can be combined in order to create the desired parts. Each of these methods has its limitations, and parts which are difficult to create using just one or the other method can be created by using combination of both methods. I will probably come back to this later on when I introduce you to one of the things we have. Combined solid and boundary representation can be combined in order to create desired parts. Each of these methods has its limitations. Most commercial solid modeling systems hybrid use both of them. 3D feature based solid modeling is becoming the preferred modeling of mechanical engineers everywhere, especially things which involve fabrication using conventional fabrication process. Feature based models allow operations such as creating holes, fillets, chamfers, bosses, pockets to be associated with the specific edges and faces. When the edges or faces move because of a regeneration, feature operation moves along with it, keeping the original relationships. This is the genuine growth which we intuitively do in our brain when look at the objects themselves. If the features are not referenced correctly, they may not end up in the correct place, the models are generated. So, we have this stuff about something which will be in the center to the edge and so on. It is a matter of initial training and tremendous experience. And generally people try to stick around with known limitations, and luckily for us the fabrication shop has a limited number of various operations. If you are to take a hexagonal headed screw, an Allen key, the key dimensions are fixed, the head dimensions are fixed. Understand? No? We have a key, then we have a head in which hexagonal key is there, head dimensions are fixed and height of the head is fixed, and then at the bottom various screw proportions and all are fixed, probably started by DIN, VSM and eventually adopted by SI and ISO various dimensions. The advantage of this is they are nearly interchangeable, and CAD packages make use of it. In fact, it is a library components which are available directly. If you want a M6, the length of maybe 24 mm, the whole set is available, downloadable from the internet and sometimes built into the packages. Read it yourself before I read it with you. So, you see here parameters related to any primitive can be associated with it. So, two ways: bidirectional, that is, if you want you can edit it and automatically things get updated. Alternatively, if instead of your typing in the dimensions, if you modify something there, the dimensions get changed. Magic is real process involve using cutters, involve what you call routers, and involve end mills and all that. No, they all come in steps. Like inside, if you take a mill for making a routing, typically a 4 end mill is a reasonably tough or stable object which is available in that. Unless you want it very, very small, the corner radius can afford to be about 4 and then in case something square has to be put, they take it into the corners and so on. These things can easily be incorporated into your model. You see, the second important thing is these modelers, you just read the first one. I will read it in myself before I start. So, the first para talks about which is the best part by simply adjusting the model parameters and regenerating the part. So, several of these parametric based now have a beautiful history. Only when you make a what do you call, when you attempt to use and make a piece, you will understand. Somewhere you would have made a starting point saying, in our case of electronics, I will say I have started with locating a connector on one side of a enclosure, and then I have put a printed circuit board which comes near it. Now you see there is a chance of something attaching with each other. If there is a way, if I tie up these things, I can avoid the unintended interference within these objects. So, all I need to do is now I lower or higher, change the PCB height. Similarly, I can change the connector position, and then other things related by it can be made to update themselves automatically. You see here, some of the parametric modelers allow constraint equations used to construct relationships between parameters. If several parameters require the same value or a certain depends on the values of several others, these relationships are always correct. So, unless you face it and try it, this high level of generalization and abstraction probably will not make sense to you. One example, one very small example I can give you is, which is not really the crux of it, is, let us say you start your program by using 3mm screws and cheese head screws, and then we know that 3mm cheese head screws have probably a washer, and then there is a spring washer associated with it. If you correctly tie up all these things, we suddenly find out that for some reason you need more space. You can reduce the size of the washer and then associate things like if you have a counter bore, all of them can be taken care of. Alternatively, if the material, especially if it is plastic and all that, is likely to fail, you can increase the size of the washer and then make sure related buses and all get updated automatically. There is just one lone instance or anecdote I am trying to tell you. I am not claiming that this package will do it automatically, but in the case of mechanical things like bearings and all that, it does work. It looks very easy as to how to select a bearing. Go to the catalog and select it. Only when you actually physically try a object, then you will notice that there are constraints. I wish I had another object like this. You have seen here the slide there shows about how entities can be located. So, my next slide shows you where to put the various parameters. So even if I were to talk about a watch like this, which is actually simple, there is nothing much about it. So it looks like you can put this what they call illuminating button anywhere you like. Similarly, you can put all these things anywhere you like. But if you can tie them, entities can be located at the origin of curves, end of lines or vertices, midpoints of lines and faces. Similarly, can be located at a distance at the end of a vector from these points. So if I read it, I mean kindly read it yourself because I had a little mixing problem. Kindly read it for yourself. So in the first para last line insists that if you can have things which are parallel, tangent to something or perpendicular. So if you are talking about a belt drive, it looks simple. If you want to increase the torque, reduce the pinion. If you want to increase the speed, same way, reduce the pinion, and then it is possible to do this. But then what happens to the length of the belt? And then if you keep the belt constant, maybe center distance can alter the items. So you see here the second para talks about is efficient working with designs which undergo dimensional changes rather than gross geometric ones. Next slide. Dynamic modeling uses flexible model creation and refinement concepts to allow designers to capture ideas in detailed models without focusing on the underlying history. It allows creation of features that are not fully dimensionally constrained. I thought I will show you this. Me being a mechanical engineer, I am very easy for me to create such objects. You see here, this one is a little like a hinge, except there is something very special about this hinge. Sir, can I have the main camera? I have a hinge in my hand, which is conventionally what you will fit for a what do you call a box. So this hinge, sir, can I have the camera? I have a hinge here which is a small, I mean it's by no means small because it seems to measure around 30 millimeters. It has a little problem that it goes back unspecified length. See, it goes back by an unspecified. I wanted to stop here. Similarly, I wanted to stop here after it goes here. So I went about trying to make a hinge, which that animation you have seen. You see, some very interesting thing is by adjusting this edge. I have an edge here. By adjusting the edge here, I am able to make sure that it goes down by adjusting this feature, and then to make it move smoothly, I need to give a radius there. This has been somewhat simplified. By the same logic, I can probably make a smooth surface here and then try to see how well. This is typically one way of, it's a, I do not know, I mean I am not very familiar, rather I am not able to remember because each package uses its own names. You see here, to make it visible, a small radius has been added here in the corners, and this line here represents that these things are surfaces. So, it is surface with the edge visible and so on. But in the engineering view, you will notice that dimensionally it will be perfect, but for you to understand or make the object, it is not that easy. But when I am talking about how this geometry, how it fits and all that, it does make sense. So, this is where various types of operations have been done. This is a little, not actually a wireframe model, but then it shows the surfaces that are attached to each other, because the edges are also shown, and edges have a small radius built into it or a fillet built into that will ensure that will be visible. See this here, this is not the actually real original object. A small radius has been made here such that it can be done, and then you see other extreme how it stops here. This is slightly different from the earliest that models I have seen. You have seen that slight amount of shade has been given to them to make sure that these things look slightly better. Okay. So, we have all these nice things here. I am trying to load up the one of the what do you call beta versions of a package which I have. I hope it opens. Okay, and I'd like to thank the McNeil Associates who have been good enough to give it to us. You see here, if I now go to this window, something very nice can be done. I can see it for every view, how it fits, whether there is an interference here in the scene here. I do not see any interference at all. Now, if I were to rotate this object, see here, there is a clear gap here by which things move smoothly. Then I said, me being a mechanical person, I get thrilled that these packages are able to do these things for us. So, we have huge number of options that are possible and a huge number of packages that are available. I thought maybe this is the one I was reading out from you. Okay, this is something I have retrieved it only this morning. I suggest you two people go and ask for what are all the various available packages that are available in the market, and then some of them allow you to download a trial version, and if you are a student or a first time user for a short time, it is nice to make them eventually you get what you pay for. So, if you pay the full whatever is there, you get support and upgradability in case you change your platform from a simple PC eventually to a workstation, or you have a terminal which is the other workstation, because we had release 12 netware version from Novel for a long time, until when we checked out our Novel netware and we moved on, we got support, and then eventually after that we have moved out of that whole space of teaching CAD, and then students learn the other softwares from the college. At the undergraduate level they work, and then we will go at the graduate level. So, things have been moved out, though the other people use. Now, coming back to my monitor there, you will see that one of the earliest things is the Autodesk design suite. If you think of mechanical, first thing that comes to your mind is AutoCAD. AutoCAD is developed and distributed by Autodesk, used for creating 2D drawings and can be used for 3D. In my opinion, 3D modeling and so on and so on, it's the best software. But again, it's an opinion about the person who has compiled this thing. But I am sure the people who are familiar with it continue to use it, and then they export including a solid model. They start here, export it to a package there, and then you will be able to build on it from there. And then even now the Autodesk DWG, DXF and IGS formats, and especially DWG starting all the way from release 12 to I think 2000 and all that, have almost become industry standard and generic. So, whenever you go somewhere, you can see save as, you will find the particular thing to save. Later on, Inventor now, what do you call, it's a beauty for people who started with Autodesk suite packages. Easy for people to learn, and then in case you have started, especially when the HP and the Houston printers came, somehow that printer format and Autodesk's things matched very well. With any problem, we could take prints, and backup is out in the market. You can just upload the your whatever file you have, and they fit everything neatly depending on whether you want a A1 or A0 print. Nicely they come, and then even today it's worth keeping a print, because my floppies don't work. Original, we also have, nobody will believe that there was an 8-inch floppy. They don't work anymore. Then we have 5-inch and all that. Even sometimes I find that corruption takes place in hard disks. Pocket hard disks also have corruption. So, whenever you have signed contractual thing and all that, no, original hard copies are still kept somewhere. And for this purpose, the original Autodesk formatting and printing still works very well. And by default, anybody else also gives you backward compatibility. And I am sure lot of you have come to good old Pro E. Creo Parametric, normal as professional engineer, is developed and marketed by Parametric. It's a CAD CAM CAE supported software. Unlike the earlier, the Autodesk suite, which is only little to do with drawing, design and making things, this particular Pro E became much more mechanical than simple computer aided design drafting. It had various advantages, including what do you call parametric feature based 3D modeling. So, if I have a square cutout, what will happen to the corners? Have a beautiful opening. What will happen to the 3 edges? What will happen to the inside edge? And what will happen to the corner of 2 edges and then 2 edges meeting here? These things are taken very, very well in Pro E. Best probably, while I have not used it, I have seen my students and fabricators use it. They seem to understand this well. But parallelly, both Siemens and Dassault came out with their own fantastic software. Dassault's CATIA competes with Pro E as well as AutoCAD's other suite, especially as they have written here, Inventor, particularly used in industries where rich surface modeling is needed, such as aerospace and automobiles. When you are talking about surface modeling, a thing like a mouse is simple compared to an automobile, where even a thing like your front fender is a big issue. And then aircraft, we need not tell you about how complex it is. And finally, in relation with aircraft and automobile, things like a front dam for keeping a Formula car down, it's special. Aircraft has flexibility and what you call surface transport has flexibility, but when you are talking about the spoiler and we are talking about this dam and various things, that is really something. They keep the drag coefficient down, and while we talk about lift to drag, surprisingly it is the other way in the case of surface transport at high speed. Instead of lift, we want a clamping down force. As a technical word for it, which I am not able to think about. So, CATIA was born out of this requirement by the Dassault people. I do not know how to pronounce these words. Put up with me, or rather my accent. Siemens and Unigraphics solid edge are inseparable. So much so that our undergraduate program in the place in Bangalore, all colleges teach either solid edge or SolidWorks from their I think second year of engineering studies. I am happy, or rather, well, I am not apologetic for it. I am proud to say I cannot work with these packages as well as the students. Students have started, learned it young, and then without too much effort, they are able to make really complex solids. Seen that? So, anything I want to make here, most of the majority of things which have been presented, are going to be presented, have been made by my graduate students who, when they were young, like when they were 19 years old, they started with either solid edge or SolidWorks. Works beautifully. And one of these, this SolidWorks, I think has fantastic sheet metal capability. So, all that which I have shown you about how to add a bending allowance and then how things interfere with each other, how to make notching, all these sheet metal works are available in these packages. So, what looks simply as a some general talk about CAD, you will see that CAD has come to a very, very forward place. Well, at one place, as I said, things like mold flow analysis and things like in the case of aircraft, we have analysis about drag and lift and all that. Same way in sheet metal, tremendous amount of progress has been made. If you can make the start with an original drawing, there is a shell command which will make things into a thin shell, and then you can bend things, you can make, which can be used for any other thing. So, we have so many of these, Ashlar, Vellum, 2D, 3D CAD software. Then these bottom ones, I have not used all this, but then if you go, we have a few things like the Google's Sketchup. I am not very good at it. So, Sketchup is developed and marketed by Google. Pull, move, fill, combine techniques and so on. I suggest you go to this Google's place, and then we have so many of them. So, I will go back here again on top. So, we have the Ashlar Vellum. It has a huge mechanical parts library and parametric modeling. Similarly, 2D mechanical, which are easy to learn. The very complex things are a little difficult to learn, but the ones you learn, you can manage very well. As you go down, Sketchup is available. Any of you who are just curious about it, you can try this Sketchup. Then we have FreeCAD, open source parametric 3D, and this is probably, we have come to the end of this listing of the various packages. My suggestion is, please go back to the net and then try one more time what are all available, and in case you are in a group or in a friends circle, you can always learn from them. Otherwise, any of these packages have their own tutorials and things built inside, and some of you can afford it and do not have time, can probably join a class where they teach you the fundamentals. It is expensive, but expect that you get support with the package in case you are stuck. They won't think you are a dumb fellow or asking the same question and again and again. So, you can get help from them. Otherwise, I am sure several of you intelligent, in fact most of us do not read the instruction manual anymore. I will end this talk with the thing, if nothing else works, read the instruction manual. So, in our case, if nothing else works, keep trying or get onto a blog, and then you will get information about how to attach surface characteristics, how to give a bump or a texture file to a surface, how to adjust the lighting and all that, which is actually beyond this, except that I wanted to introduce you, saying you try to make this. If you see, one of the GIF animations was created using some solid modeling software, and it is done in a very crude way. It does not use proper animation things. So, it was stored with every 15 degrees something was rotated and we ran through it. If you have a proper animation software, you can probably have a handle and make things move and see how well things move. So, thank you. If nothing else works, keep trying. Thank you.